Hello, my lovely people. We are now doing 8-3 conditional probability, which is going to be our last lesson in probability in Unit 8. Lucky for you, it's a really easy one. Okay, so let's start with, the title is conditional probability. Oops. But before we get into that, we're going to define a two-way frequency table. Okay. It's a really fancy term for something that displays relationships between different sets of specifically sets of data. Okay, so what does that mean? Well, very simple. Let's look at example 1 here. This was like a survey that was done, for example, where we surveyed, let's say, 9th and 10th graders to see what is their preferred pet: bird, cat, dog, fish. So out of the survey, you have two sets of data. You have what grade they're in, right? Going right here. And then you also have what their preferred pet is, which is going to be these right here. So we're going to find the probability that a 9th grader prefers fish. So what do? We look at 9th grade, which is this row here, right? And then out of those, which ones prefer fish? So you see how they're kind of overlapping right here. Let's do this color here. So this 22 right here is going to be the probability, or that's the number of 9th graders who like fish. So what we're really finding is how many 9th graders and how many like fish. So remember, this notation means and. It's called intersection, but it means and. All right? So that's going to be 22. And then we need the total number on the bottom. Well, how do we get that? Oh, well, you simply add up, because it doesn't tell you how many people were in the survey. So we actually have to do that, those calculations ourselves. Okay, that's pretty simple. So you're going to add up all of these right here. So that's going to be 3 plus 49 plus 53 plus 22 is 127. And then you do the same thing for 10th graders, because we need to know how many 10th graders there were as well. So you add 7, 36, 64, and 10, and that is 117. So we have 9th graders plus 10th graders, and we get 244 is our total number, right? So that's going to go here on the bottom. And then last but not least, you simply want to simplify that down. Sorry, I don't know why it's being so slow. There you go. Okay. 22 over 244 would simplify to 11 over 122. And that would be your answer in simplest fraction. Probability that you're in 9th grade and you also prefer fish. Okay? Yeah? Not bad, right? Okay. Let us continue. So this is the actual title. The topic is conditional probability for this lesson. All this means, the name kind of gives it away, right? It's the probability that some event will occur given that another event already occurred. Okay, so your condition. What's the probability of something happening if this condition occurs? So there's a notation for that, which is going to look like this: the probability of event B happening given, so it's like this vertical bar, the event A is happening. So that is read as probability of B given A. And so this word given, that's going to be a really important key. Given right there. Whenever you see that, you know you're dealing with conditional probability, and the notation is this horizontal bar here. So that means given. Okay? Okay, so the formula that you need to know is the following. The probability of B given A is, essentially, it's the probability of A and B. Remember, this right here means and, this intersection here, divided by the probability of A. But another way to think about that is this right here, the number of A and B on the top, and then the total number of A on the bottom. So whichever one kind of makes more sense for the problem. Okay, so we're going to look at this example here. It's pretty straightforward, simple example. Okay, it's another survey one. So you have surveys done in which 81% of the people surveyed can play an instrument, and then 23% can play an instrument and they know how to tap dance. So we want to know what's the probability a person at random can play an instrument given they know how to tap dance. Ooh, that's fun. So I'm going to use T for tap dance, okay? And let's use I for instrument. So we're looking for the probability that a person can play an instrument, I, given that they know how to tap dance. Right? Okay. So we want to do, let's go back to our, oh, wait a second. 81% can. Okay, so I just realized that I didn't give you all the information that you need here, so I'm going to add to this. All right, so hopefully you're paying close attention and you're actually listening. You're not just writing, otherwise it's going to be confusing. So I want you to add to this. Also in the survey, 52% can tap dance. Okay. And so that is also our T, right? Okay, so we have I for instrument, T for tap dance, and then we also know that 23% right here, 23% can play an instrument and know how to tap dance. So that's both of them. Okay, so anyway, sorry about that. We want the probability that a person can play an instrument given that they know how to tap dance. So if this is our notation, instrument given that they can tap dance, the formula is the probability of I and T, so both of them, divided by the probability of T. So this one that is on the bottom is always going to be that's your condition or your given, okay? And it's always the one that is second in your notation, right? Okay, so remember how I said here that 23% can play an instrument and, there's that word again, know how to tap dance. So that's going to be our top number there, I and T. So that's 23% on the top, divided by, or you can do 0.23, right? It doesn't really matter, divided by the total number who know how to tap dance. So that was up here, 52%. That's why we needed that. It's important that that was not left off. We don't actually need the 81% in this case, right? We only need the probability that they can tap dance. And then you just use your handy dandy calculator. Let's find that. Okay. So 23 divided by 52. That's going to be 40.44, which is approximately 44%. So whichever way it asks you, usually Pearson wants a decimal, right? So there you go. Okay. Make sense? Good, good. All right, so we're going to do another frequency table example, but with conditional probability. So what's the probability that in this survey, you choose a song at random and it is a country song given that it's not Henry? What's happening here? Oh, okay. So this is a survey taken of 3 students, Billy, Sally, and Henry, and they were surveyed to see what percentage on their iPod, or I think the actual thing said MP3, right? Player. That's funny. So basically, for their iTunes or whatever, what's the percentage of rock music, country music, or R&B for each kid? Okay. So what we're doing with this example is figuring out the probability that a randomly selected song out of all the songs is a country song, but it's not on Henry's iPod? Kind of a weird question there. Okay, so all we need to know is that it's country given, not Henry. So remember, this second part is our given condition. So the formula would be the probability that it's country and not Henry. So I'm going to use my notation for not, which remember is this little c here. That means not Henry. And then divided by not Henry. Okay, so we have to look at out of all of the country music options, which are these three, which ones are not Henry? So we have to now eliminate Henry. So it's a little different than before. So this is actually going to be a combination of the 0.05 and the 0.18. So 0.05 plus 0.18. That would be all the not Henrys that are country. Yeah? And then the bottom, we just need which ones are not Henry. Okay, so that's a little different here. So I'm going to use another color. Let's do blue. Okay, so we want the total that's not Henry. So basically, we have to eliminate all of the Henrys because we want not Henry, and you want to use all of those percentages. So we actually have to combine all of that. So 0.21 plus 0.10 plus 0.05 plus 0.18 plus 0.55 plus 0.32. Okay, that makes sense? I know it's kind of weird, but not too bad, hopefully. All right, so let's add. 0.05 plus 0.18 is going to be, let me move this over because I'm going to run out of space. Okay, is 0.23 on the top. On the bottom, we need 0.21 plus 0.10 plus 0.05 plus 0.18 plus 0.55 plus 0.32 equals 1.41. Okay, so now we just divide. 0.23 divided by 1.41 is 0.16. Ta-da! Or 16, approximately 16%, because it's actually 0.16312, blah, blah, blah. Okay, so when you see this word not, don't be confused by it. You just want to make sure you're eliminating all of those Henry options there. Cool. Okay, this next part, I'm going to kind of separate it because it's a little bit different. So we're kind of still similar, but a little different. This is important. You'll need to know this from your homework, but we're not really going to do an example with this because you've already done it. But I wanted to remind you that if A and B are independent, then the probability of A and B is equal to the probability of A times the probability of B. And actually, it looks like I'm about to be cut off. Well, I have a few more minutes, but I want to make sure I'm not cut off for this last example. So I apologize. You're going to have 2 videos, but the second one's going to be super short because that is it. Okay? I just don't want to rush through it and then not be able to really fully explain this last example. Okay? So I'm going to pause here and we'll go to the next video. Cool. By the way, y'all are wonderful and beautiful and awesome, and I miss you. Okay.